So now today we continue with moving charges, which is known as electric current, right? So today we are going to discuss about the motion of charges, or you can say that the movement of charges. So when we discuss about the motion of charges and in previous class we discuss about rest charges, right? When there is no flow of charges in there, there is only a transfer of charge can be produced with the help of friction or induction, right?
Yes.
So when we discuss about the motion of charge or the movement of charge, so first of all, if we define electric current, so basically current word can be used in our daily life also. Current basically tells you about the flow of anything, right? So in this particular topic, it is related to the flow of charges, right?
Yes.
So if we want to define electric current, so current can be defined as rate of flow of charges, right?
Yes.
So this is the basic definition of electric current, that is known as rate of flow of charges. And if we want to write the formula for it, so first we need to know about the symbol for electric current. So the symbol for electric current is capital
Amps.
I, and ampere is the SI unit, right?
Yes.
And if we discuss about the formula, so formula is equals to I is equals to Q over T, right? This is the formula for electric current, and capitalize the symbol of electric
Ampere.
current. Ampere is
Okay.
the SI unit, right? And this
Okay.
Q represents the charges, and we already know about that the word rate represents the time,
Okay.
because whenever we use word, because in previous topic we also use word in rate, word in velocity, acceleration, momentum, and many times we use the same concept of rate. So the meaning of rate remains same, that we are going to divide any quantity with respect to time, right?
Yes.
So in this particular section, we are going to divide charges with respect to time, okay?
Okay.
And the ampere, which are you saying about that? That is the SI unit of this particular set of electric current. So when we are going to discuss about the SI unit, so the SI unit of electric current is ampere, right? Or in short, we can write only capital A with it.
Ye-
So let's suppose if there are
Yes.
10 coulomb charge are flowing through the circuit, and there will be a time of 1 second. So we can say that there will be a value of 10 ampere of electric current, right?
Yes.
So the concept of electric, right? So we are only going to discuss about electric current this time. And further, if we continue studying about electric current, so normally there are different sources through which we can study the electric current in our circuit, right? Let's suppose if we take the example of a battery or a power supply or a normal power supply in our houses. So there are different sources of electricity, right?
Yes.
So if we categorize these different sources of energy for electric current, so we can say that there are two different sources, or we can say that there are two different categories of electric current through which electric current can be supplied to the circuit. One is known as DC, that is direct current, and the second one is known as AC, alternating current, right?
Yes.
DC represents direct current. So if we first discuss about the direct current, so what is the basic concept of direct current? Direct current means current can only flow in one direction, right?
Yes.
So we can write or explain direct current as that flow of charges in only one direction, right? And what
Yes.
is the meaning of this? That charges will flow in only one direction. So only one direction means, let's suppose if we connect a battery to the circuit, or we can say if we are inserting or connecting a battery in our mobile phone, right? So you can see that when you fully charge your battery of your mobile phone, laptop, tablet, or anything, so current will only flow from the battery to the circuit of that laptop or electronic device, right?
Yes.
Or we can take the example of cell also. Let's suppose a cell is connected in a toy, in a clock, in a remote. So current is only flowing in one direction, that is from the source, which is battery or a cell, to the circuit of remote device, mobile, tablet, anything in which we are using the cell or the battery. So in that sense, we can say that current is only flowing from one direction to the other one. So the flow of electrons or the flow of charges is only in one direction. So that current is known as direct current, right?
Yes.
So if we write the sources for this, so the sources will be of battery. So there are different sources of direct current. Most common are cell, battery, and power supply, right?
Yes.
Because when we are going to use variable voltage or variable electric current in the circuit, so we normally use power supply, because power supply have a different range from cell or battery, because cell and battery has fixed voltage and electric current, and power supply is in our control, and we can manage electric current and voltage according to our requirements, right?
Yes.
And further, if we discuss about their graphical representation, so if we discuss about their graphical representation, okay, so we are discussing about the graphical representation of direct current, that is DC in short. So when we are going to plot the graph or the journal graph for DC, we are not going to discuss in detail at this time or in this chapter, but we need to know about the basic representation of the graph for DC. And if we discuss about the basic representation of graph, so we can see that according to the formula, there are two quantities, charge and time, right?
Yes.
So if we plot a graph, so graph will be between charge and time.
Mm.
Let's suppose if there are two axes, and in this graph you can easily observe that there is a time on x-axis, right? And
Yes.
electric current on the upper side and electric current on the lower side also, right? It means that
Uh,
the upper side represents the positive and the lower side is the negative. And the significance of negative sign is that negative sign is not showing that current will be in negative value. Current will not be in negative value. Negative sign basically represents the direction of electric current, right? Or
Whether it is positive or negative,
no, in
like
not in
how?
that sense. In that sense, let's suppose if we are connecting a cell in a circuit, if we connect that circuit in the reverse order, right? So our charge will flow in the opposite direction. But where our circuit will not complete because our circuit is designed to flow charges from one direction only. So if we connect a battery or cell in the opposite order or in reverse order, so that will give you the negative value, right? Let's suppose if we
Yes,
connect an ammeter, which is used to measure the electric current, right? So that will give you deflection in both sides, towards right positive, towards left negative. Negative basically represents that you connected that source in the reverse order on the opposite direction, right? So charge will
yes,
flow in the opposite direction, but because your circuit is not complete, that's why your device will not work, right? So you need
yes,
to correct the direction of that source, then current will flow because circuit will complete, right?
yes.
So that's why I mentioned positive and negative. Negative is the reverse order, right? So if
Okay.
we draw the graph for it, so graph will be like, this is just a journal and rough sketch of DC. We are not going to discuss in detail at that time. Remember that we will discuss this graph in detail after, when we are going to discuss about the electric circuits in detail, oscilloscope in detail. But for the time being, you just need to know about the representation, right? And you can
Yeah.
see that I only represents this green line on the upper side, right? So it means
Yes.
that our current is flowing from one point to another, right? And there will be a variable graph. So it means that current may be increase, decrease with respect to time, right? Let's suppose we switch on the button, current is start flow, then we turn off the button, current will comes towards zero. Then again we
Why
on.
is why is variable used?
That variable is used. Let's suppose if power supply is connected, right? And if we increase
Yes.
the value, so current will increase, and if we decrease the value, current will decrease. Let's suppose we start from 0, so graph starts from this point, that is 0, and we increase to 5, then we again decrease to 0, then again we increase, again we decrease. So current will only flow in one direction, you can see, either in positive or either in negative, right?
Yes.
It depends upon the orientation, right? And if we draw a very
Yes.
simple graph for it, right? If there is a fixed value of electric current, let's suppose if cell is or battery is connected, so battery and cell will give you exact value, right? A fixed value.
How?
Because when you connect a cell, so you can easily observe on the cell or the sticker of the cell or battery that the voltage is mentioned over there. Let's suppose if cell is of 1.5 ampere, so it means that cell will give you 1.5 ampere electric current. Or let's suppose if voltage is given there, so further when we discuss about these quantities, so we can calculate the value of electric current with the help of voltage also, right? So in
Yes.
that sense, we can draw a fixed type graph.
Mm. So at that time, the cell and the battery, they both have the same ampere.
Yes, because there is a fixed value, we cannot change the value according to our wish, because now cell is completely already uh, designed there. We can not change according to our willing. So we can only change the value of current and voltage with the help of power supply, because power supply has option just like the regulator of the fan, that we can increase the speed of the fan, decrease the speed of the fan, right? So that is variable, so that is in our control. And if let's suppose there is no regulator there, right? So fan will only start moving with a constant speed, because there is no regulator there, no option to change the speed of the fan. So fan will also always moves with a same speed, right? So that is the fixed value.
Yes.
So if we try to draw the graph for that purpose, so again we take positive and negative. And in this graph, now if the value is fixed, so either let's suppose if there is a value of current that is 2 ampere, and also on the negative side when direction is opposite, so current will be like a straight line, right? That with the passage of
Yes.
time, current will be same until the charge or the charge of the battery or the cell will get completely consumed. So until it will provide the constant value of electric current, right?
Yes.
Just like the example of battery, when we are continuously using our mobile, so our percentage of battery will decrease, right? Because charges are continuously consuming from the battery. So that's why the percentage of the battery will decrease.
Yes, exactly.
Or either in
So,
negative direction if we connect in the reverse order. So I also mention over here that this negative line represents
oh,
that
sir, what will we find? What will we find if we find the gradient of this graph?
you can find from the gradient of this graph that there are two quantities, current and time. So you can calculate the charge, that how many charge are going to be transferred into the circuit, right? Because there is a
Yes.
relation between electric current, charge and time. So if two quantities are mentioned there, so third quantity can be calculated with the help of gradient of this graph, right?
Yes.
Let's
Okay.
suppose if there is a value of time over here, suppose if there is a value of time 5 seconds, right?
Okay.
So if we multiply time with the electric current according to the formula, so you will get the value of 10 coulombs, right? This one.
Yes.
So it means that 10 coulomb charge is consumed by the device or the circuit, right? According to this graph.
Okay. The the symbol, no, the unit of the charge is
Coulombs,
coulomb.
coulombs, yes, see. We already discussed in the previous chapter, and I hope that we will discuss about that. Yes, here it is, SI unit coulomb C. Okay. Okay, so that is the symbol of electric current and that is the graphical representation of DC. And now if we discuss about AC, so there must be some difference. That's why these two categories are different from each other. So if we start discussing about the AC, so the full form for AC is alternating current. And by word alternating, we suppose that the direction of the current is continuously changing, right?
Yes.
So if we discuss
Uh,
about the
it have
alternating current,
multi-value variables.
no, only we discuss about direction because
It
value,
have multi-variables.
yes, multiple variables means multiple direction, and multiple direction means it is bi-directional. Current will flow in forward and in backward direction, right? Because there is only two possible
Mm.
direction for electric current because circuit is connected, so either it will go forward, otherwise it will come backward, right? So only two possibilities are there, right?
Yes.
And if multiple connections are there in a single socket or in a single power supply, so each individual device has its own direction of electric current, right?
Yes.
So if we define the definition first, so alternating current will be the direction of current, direction of current will be alternate, and alternate means its direction is changing, right? Current will flow in forward direction, and after some microseconds of time current will also flow in backward direction, right? And if we discuss
Yes.
about the example or the source of AC, so one example is of power supply, because power supply are available for both AC and DC, right?
Yes.
And the other one is the connections in our normal house. So in that connection, the main power supply in which we connect our devices of charger or refrigerator, LED, LCD, anything we are going to connect in our house. So that current is known as AC, right? Because we use AC in our houses because we need continuous supply of electricity, right? Let's suppose
Yes.
if we use DC in our house, so the DC source will eventually come to the zero at after some time, right? Just like the battery. So what
Yes.
happens that after we need to charge that source again, right? And when we charge,
Yes.
so it will take some time, and we need also a source of charging over there, right? So that will become very complicated. So our life and our devices with electricity that are connected with electricity becomes very complicated, right? So we can
Yes.
easily observe that in our society or in our town or in our area, there is a PMT over there. And the purpose of that PMT is to provide electric current and voltage in that specific area, right? Let's suppose if we
Yes.
replace that PMT with a battery, a huge battery over there. So that battery will provide electric current and voltage to the house, right? And let's suppose if a single house is using a large amount of electric current and other houses is not consuming that charge, so battery will consume. And when you are going to use electricity in our house, so battery will comes down to the zero. Then we need to charge that huge battery, and if we are going to charge that huge battery, so it means that we need also a very large amount of charging source that charge that device which is replaced on this option of PMT. So that's why DC current is not suitable. So that takes some time to charge, then it will provide electric current and voltage to the houses. So that is not suitable for our normal daily life connection. So that's why we use AC current, because in AC current, current will flow in forward and in backward direction in very short interval of time, right?
Yes.
So the supply of houses is also consist of AC current. And if I give you the example of that, how many times current will go forward and backward in 1 second. So each country and each city has its own frequency of electric current, right? Because you
Yes.
can see that there are different devices. Let's suppose if we import something or export something from our country or from some other country, so on the box, or you can say that on the packing of that device, there is a fixed value of electric current, voltage and frequency mentioned over there, right?
Yes.
And in our houses, we normally use a device that is known as stabilizer, right? And the
Yes.
purpose of that stabilizer is, let's suppose in that specific area, the value of voltage is pretty high as compared to the normal one, right? So that stabilizer will, you can say that that will operate the voltage, that high voltage or low voltage according to our desired voltage, right? Because our
What
devices,
will we do again? What it will do again?
that device basically, you can say, manage the voltage. Let's suppose in our house there is a requirement of 220 volt, because normally in Pakistan or in every country, not there is not a very big change in electric current, voltage and frequency. So the average voltage we required in our houses, so that voltage is normally around 220 volt. We will discuss this concept of voltage. So this is the average value of voltage that a normal house can obtain, right? But let's suppose in
Yes.
some specific area, voltage is greater than 220. Let's suppose in that area, voltage is around 240. So that is high according to our desired value, right? So we
Yes.
use stabilizer to maintain that voltage according to our desired value, that is 220, right?
Mm.
So this kind of thing we are also going to discuss in our detail in our next chapters, right?
It's
So
like it's not compulsory to use it. In my house, there is 120, and we have a fridge of 240 volts.
yes, if
So we
there,
use a volt
yes,
changer
yes, you
of
don't need to
something
use
like that.
that one, because in your refrigerator and in devices, whole circuit is completely designed according to your required voltage, input voltage and output voltage. So all components are already connected there, right? But for safe side, we
Yes.
use stabilizers in our normal house, because let's suppose if there will be some fluctuation in our area, right? So our devices will got damaged, because that both these those are electrical appliances, and they are depending on electric current, and there will be no control over electric current. So we cannot control that electric current of that power supply which are coming from the outside. So sometimes there may be fluctuation, and that is very rare case. Not every day or in every month or every year it happens. Sometime it will happen. So that will be the fault somewhere. That is not very important. We are not going to discuss about that one. So I'm giving you the rough value. Let's suppose in my country, let me say the frequency of electric current is between 50 to 55 hertz. So
Mhm.
50 to 55 hertz means that current will flow forward and backward 50 to 55 times in 1 second, right?
Yes.
So the flow and the change of direction of current is very fast, that in 1 second it can move 50 times forward and in backward direction. So this process is very fast. That's why we cannot observe that AC current, right? Because let's suppose if this frequency is very much low, so there will be a glitch. Our light will become bright, dark, bright, dark, bright, dark. Because when current is flowing in forward direction, the light will glow brighter. And when it is moving in backward direction, so it will become dark, right? But the process is very fast.
Yes.
That's why we cannot observe that AC in our houses, right? But there is a
Yes.
supply of AC in our normal houses. And if we want to draw a graph for it, just like the DC, so what will be the graphical representation of it?
Mm.
Again, we take the same y-axis, same x-axis, and now we are going to draw graph for AC. So let's suppose again there is a positive side and the opposite side, because now current will move in both directions, right?
Yes.
So if there is will be a variable power supply or power variable source of electric current, so current will move in forward and backward direction like this, right? Or if there
Mm.
is a
Can we
fixed
know?
supply,
Can we know which one is forward and which one is
the
backward?
upper side is forward because that is plus, and the lower side is negative because that is minus, right?
Okay.
And same if we are going to work with a constant AC supply, right?
Mm.
So for constant supply, we can say the graph will be like this, right? So in this
Okay.
square diagram, we can easily identify the value of electric current. But in variable, it is difficult to identify, right? Because there is a curve and we need to identify each and every point on the curve. But in a square box diagram, it is easy to identify the value of electric current, right? Because there is a fixed value, and that will be much easier for us to calculate the electric current. But that is not compulsory for the time being to calculate the exact value. So we are just going to discuss about the graphical representation. Now you can easily observe the difference between the graphical representation, that the graph for DC is very much different from AC, right?
Yes.
So any confusion between this?
So the second graph here in this page, is
Yes,
for what?
this is also for AC, but in this AC, the value of electric current is constant, or the AC supply is constant, right?
Yeah, okay.
Because if we take any part on the graph, let's suppose at this point, so you can easily measure the value of electric current. If we take this part, you can easily mark the value of electric current. But in variable, you can see that there will be a direction changing and there will be a variable graph. So it depends upon the situation. We will discuss in future in this when we discuss about detail in this topic and when we are going to solve the graphs, right? But for the
Yes.
time being in these chapters, we are not going to solve the graphs, right? We just solve the numerical values. Okay.
Okay.
So these are the difference between AC and DC. Okay. And if we discuss about the flow of electric current, right? So for the
Yes.
flow of electric current, you we first previously discussed, or we know that if we take example of a battery or a power supply or any source of electricity, so we know that there is a positive terminal and a negative terminal, right?
Yes.
So this will be the positive terminal and this is the negative terminal, right?
Yes.
And we'll discuss about positive and negative terminals. So now we need to know about that from which direction current is going to be flow, either is it positive or negative, right? So this is the
Yes.
question. So in the earlier era, or when the scientists are trying to identify the direction of electric current, when there is no, we don't have much knowledge about electric current, electricity, electromagnetism. We are in the time period which when scientists are going to invent or discover the concepts. So initially, because there is a concept of free electrons, so scientists assume that current will flow from the negative side, right?
Yes.
So the initial concept of scientists was that current will flow from negative side, or we can say that charges will flow from the negative side. Charges will flow from,
Is it true?
no, after some experiments and after the discovery of other experiments and laws, so scientists finally conclude that current will flow from the positive end, right? Because protons are fixed in the nucleus. So proton have high potential because electrons are free to move. That's why they have low potential. When we discuss about EMF and potential, then you will get the difference what is potential is. But we can easily observe from the previous topic of electrostatics that positive charge are in the nucleus, right? So they cannot move from their position. Only electrons can move, right? So that's why
Yes.
positive side have a high potential and negative side has low potential. So the previous concept is this, that charge will flow from negative to positive terminal, right?
Yes.
We need to study about this negative to positive concept because sometime in exams they ask you to draw the electron flow. And what is that electron flow? If we try to move charge from negative to positive, right? Normally it not happens, but forcefully if we try to move charges from negative to positive, so that flow of current is known as non-conventional current, right?
Hmm. Will it have electricity?
Yes, that's why it is known as non-conventional current. Current word is there, so it means there is a flow of charge, but in opposite direction from negative to positive. Or another word we can use that is electron flow. So in many questions from past papers, they sometimes ask you to draw the electron flow, right? So you need to draw the direction from negative to positive, right?
Hmm. Yes.
So this is known as electron flow, when charges will move from the negative side like this, that in this case charge will start flowing from the negative end to the positive end, right? So this flow is known as electron flow. But in our normal circuits, current will flow from the positive end, right? Because electrons are free to move and only positive have high potential because they are fixed in the nucleus. So that's why, due to force of attraction, current will flow from the positive end, right?
Yes.
So you just need to remember that normal in our circuits, current will only flow from the positive end, and that concept is known as conventional current. Conventional current, right?
Yes.
So conventional current means that charge will flow from positive to negative.
Okay.
Charges will flow from positive to negative terminal, and that concept is known as conventional current. Okay, I written spelling conventional wrong here. So conventional current. Now that's fine, conventional current. So in conventional current, charges will flow from positive to negative, and in non-conventional or electron flow, charges will move from negative to positive, right? So that is the
Mhm.
difference between conventional and non-conventional. The reason behind to study non-conventional is because sometimes they ask you to draw the electron flow. So if you don't have the concept of electron flow, so you always draw charge from positive to negative, right?
Yes.
That's why you need to remember that there will also be electron flow if we forcefully move charge from negative to positive, right?
Okay. So they will ask about electron flow from positive to negative. Like
Yeah.
how will they ask?
Electron flow will also from negative to positive, right?
Yes. Or electron flow is always from?
Electron flow will always from negative to positive, and normal current or conventional current will flow from positive to negative, right?
Okay, I got it. Thanks.
So when we solve the questions, so you will observe there that in many questions they ask you to draw electron flow, because in hurry or in exam in excitement, students try to draw from positive to negative. Then they realize they ask about electron flow in paper and they draw from positive to negative. So that will become wrong, right? So that's why we
Yeah.
need to know that there are two different types of flow. So when they ask about electron flow or non-conventional, you need to draw from negative to positive. And when they ask to draw from conventional current, so that will be from positive to negative, right?
Yes.
Okay. Now, these all phenomena and these all properties are related to electric current only, right? We must discuss about electric current. Now, if we discuss about voltage, right? Because there is also a concept of voltage there. So in voltage, there are also two terms. There are also two different terms in voltage. So first, if we discuss about that voltage are also of two types, we can say that. So in voltage, we can say that one type or one category of voltage like an EMF, that is known as electromotive force, and the second one is known as potential difference. So now we need to identify the difference between these two quantities, right?
Yes.
So first, if we discuss about EMF, because EMF is the basic, then potential difference will come in the circuit. So let's first discuss about the EMF. So let's suppose if there is a battery or a dry cell connected in the circuit, right? We are discussing about electromotive force. electromotive force. So from the name, we can easily identify that there will be a forcefully push of charges, or there will be a work done in charges because force is there. Okay, so when we discuss about the electromotive force, so what is the basic phenomena of electromotive force? So the basic phenomena of electromotive force is this, that let's suppose if there is a dry cell connected in a circuit. Let's suppose there is a dry cell or a battery is connected in a circuit. This source is known as dry cell.
Those all cells have different uh, different direction of electricity flow.
No, flow will be same, but I'm going to talk about some different concept, right? So that's why I specifically take example of dry cell or battery. So dry cell or battery. What
What
do
are
you
dry
think?
cell? What
Normal
are
cells,
dry cell?
normal cells that we used in our daily life. Because if you studied about dry cell in chemistry somewhere or in sciences somewhere, so you know about that, what is the complete structure of that dry cell, how that is cell is going to be made, but that is not important. Okay, so normal cell is also a dry cell, right?
Okay.
Normal pencil type cell which we are used in our remote controls, toys, or some other devices. So let's suppose if there is a dry cell or a battery, so we can say that there is a chemical energy, right? That cell gives
Yes.
you chemical energy. So in dry cell or a battery, there is a chemical energy. And when this dry cell or battery is connected to a conductor or any circuit, right? So
Yes.
now that energy is going to be converted from chemical to electrical, right?
Okay.
So there will be a change or a transformation of form of energy from chemical to electrical. So now chemical is going to be converted into electrical energy. So when we are going to convert this form of energy, so there will be some work done, right? We need to do some work done to convert this form of energy or transform this energy, right?
Yes.
So let's suppose if we discuss about a unit charge, a single charge is going to move from positive to negative. So we can say that the total work done on a single charge or a unit charge, right,
Yes.
to move from one point to another or throughout the circuit. So the work done on a unit charge to move that charge throughout the circuit. So that work done is known as electromotive force, right?
Yes.
Work done means that we are going to convert, or we can say that how much work we need or to do, or how much work is required to convert chemical energy into electrical energy, right? So there is a
Yes.
transformation of energy, just like our daily life example. If we want to follow our daily life routine, so we need to some source of energy in the form of breakfast, lunch, and dinner, right? So we get
Yes.
energy in different form, and we perform our routine work in different forms. So there will be a transformation of energy, right?
Yes.
Let's suppose if we take the example of gym, or we are playing some game in outdoor, so we take energy in different form and then we perform work done in form of mechanical energy, right? So food give us some
Yes.
type of energy and we are going to convert that energy. So same concept goes here. When chemical energy is going to convert in electrical energy, so we need to do some work done, and that work done on a single charge is known as electromotive force, right?
Yes.
So we can define EMF as work done on a unit charge on a unit charge to move or transfer that charge throughout the circuit, right?
Yes.
Because we first calculate for a single charge, then we can multiply with the number of charges that which we are going to calculate. So that's why we only first discuss about a unit charge, then we can multiply the concept according to our requirements, right? So this is the definition of EMF. And further, if we discuss about EMF, so this is the voltage. This voltage is linked with battery, cell, or any source. So it depends upon battery or any cell. And in simple words, if we define voltage, and I used to define voltage as, let's suppose we are going to say the intensity. If there will be a cell or a battery or a source of very high voltage, so charge will move faster, right? Because there
Yes.
will be a huge amount of energy that is going to be transferred from chemical or some other source to electrical. So this is the voltage that is linked with battery or cell, right? And
So
if we
this is
discuss,
the voltage.
yes, potential difference is also a voltage, but the concepts are different, right? Because in this condition, we only discuss about the battery and the cell, right? We don't connect
Yes.
this battery throughout the whole circuit, and we don't discuss about the whole circuit. We are just discussing about dry cell or a battery. Okay, and if we discuss about the SI unit, so the SI unit of EMF is equal to voltage, because this is a quantity of voltage, and voltage can be represented with a symbol of V, right? So
Yes.
the SI unit is voltage V, and the voltage is linked with battery and cell or any source, any source. So that is the second or the third part of electromotive force, the SI unit. That SI unit of electromotive force is voltage, and it is only connected with the battery or the cell. So it tells you that how much work is required on a unit charge to move from positive to the negative circuit or the terminal, right?
Okay.
So this is the concept of EMF, and we will continue with the concept of potential difference in our next class, right?
Yes.